SAT prep, non-calc, geometry action going on here. Intersecting lines R, S, and T are shown below. What is the value of X? Okay, so I don't have any lines parallel or anything like that, but I do have this triangle going on here from these three intersecting lines. Well, let's start with this. The 106 there, I could get this angle because it's going to be supplementary to 106. That's a straight line, adds up to 180 degrees. So that angle right there is going to be 74 degrees. Now I have a triangle. With the 74, 23, how many degrees are in a triangle? 180 degrees are in a triangle, so I can subtract the 74 and the 23. 74 and 23, that adds up to 97, so if I subtract 97 from 180, so 97, then I'm going to get 83 degrees. Now that is this angle right next to that X. What do I know about the X and that 83? Those guys are supplementary, so I'm going to have 180 minus 83, that's going to equal 97 degrees. Answer. Since this is free response, we're going to have to grid it in. Now I can put that 97 right here as the first two. That works. I could even go right in the middle there. I could have 97 like this, or I could even do 97 at the very end. All right. So anywhere you put it here on the grid, just make sure it says 97. You're good to go. You also don't need to fill this in, but you can fill it in if you'd like. The bubbles are what count. It doesn't matter what you write up top. That's just to help keep you organized. Organization is key, yo. We've got if x comma y is a solution of the system of equations above, and x is greater than 0, meaning it's a positive number, what is the value of x times y? Well, I've got a quadratic, and then I have a linear equation. Now, oftentimes we favor elimination method when we're solving a system, but because I'm dealing with a quadratic and it's already y equals x squared, I can go ahead and use substitution by plugging that x squared in for y. Now that we have this equation in one variable, we can go ahead and distribute, combine like terms, and see what we can do to solve this thing. So I'm going to have 2x squared plus 6 equals 2x plus 6. Now I'm dealing with a quadratic equation here, so I need to set it equal to 0 in order to solve. So I'm going to subtract the 2x from both sides and subtract the 6 as well. So now I'm going to have those cancel out, and I'm left with 2x squared minus 2x equals 0. All right, so what do we do here? We're going to use a GCF, greatest common factor. So I've got 2x parentheses x minus 1 equals 0. Now I can take these two and set them equal to 0. So I'm going to have 2x equals 0, and I will have x minus 1 equals 0. I need to solve both of these. So I divide by 2, and I'll get x equals 0. Over here, I'm going to add 1, and I'll get x equals 1. So I've got two solutions for x. But if we look back at our original question here, it says that x is greater than 0. So we're going to eliminate that one from this particular problem. Now I need to get x times y. So that means I need to solve for y here. So I'm going to take my working x value based on this equation or this problem here, and I'm going to plug it in. So I think really the easiest one to work with here would be that guy right there. So y equals, and then I'm going to substitute the 1 in for x. I like to use parentheses when I substitute in, and then I will have y equals 1 squared is 1, so y equals 1. And if I want the value of x times y, well, I've got 1 times 1, which is just 1. My answer is A. That was awesome. America, freedom, rock and roll. Deuces. This time we got ourselves a little geometry action going on. The circle above with center O has a circumference of 36. What is the length of the minor arc AC? Circumference? Am I going to need that 2 pi r action? No, you actually don't need that for this one. I want this length right here. Well, that arc is associated with the central angle right here, which is a 90-degree angle. A total degrees of a circle would be 360 degrees. And if I'm working with 90 of that, that's just a fourth of the circle. So if my circumference is 36, what's a quarter of 36? 9. 36 divided by 4 is 9. That's my answer. No big deal. Only a little bit of math. I like it. In the xy plane, the graph of which of the following equations is perpendicular to the graph of the equation above? Well, what does it mean to be perpendicular? That means that the lines are going to intersect and form right angles. More importantly in this question is that my slopes are going to be opposite reciprocals. Now, what does it mean to be opposite reciprocal? Well, that means that the slope is going to be flipped, and then we're also going to change the sign. So if it was positive originally, it becomes negative. If it was negative originally, it becomes positive. Now, I'm going to show you a little trick at the end of the video for this particular problem, but I think the most straightforward way of going about this is taking our original here and rewriting it in slope-intercept form. So I'm going to have to add 2x to both sides and get 3y equals 2x plus 6. And then I'm going to divide by 3. So what I have now is y equals 2/3 x plus 2. I really don't care about this y-intercept right here, but what I do care about is this particular slope right here, 2/3. So my perpendicular slope is going to be -3/2. Okay, so that's part of our problem right now. Now, the next thing I'm going to do here is I'm going to take a look at my answers, and I'm going to end up rearranging these equations into slope-intercept form to try and compare my slopes. But I can be strategic about which ones I pick because I know it's going to have a 3 and a 2 or something that's going to simplify down to a 3 and a 2. I'm going to take a look at choice A first because I have a 3x and I have a 2y. So if I rearrange this, I'm going to have 2y equals -3x plus 6. I'm going to divide by 2 on everything on both sides, right? And I'll get y equals -3/2 x plus 3. That matches what we said was going to be my perpendicular slope, so I know that choice A is the answer. We got lucky that it was the first one. That's awesome. And also there was only one choice with the 3 and the 2. Now, if it was a little bit more diverse there, or there were a few answers that were, possibilities, here's another thing we can look at. If I go to my equation up top here, okay, and I see that I have a -2 in front of my x and I have a 3 in front of my y. If I want the opposite reciprocal slope, I know that these two are going to need to switch on me. So this would become the 3 and this would become the 2. And then I'd have to have the opposite sign happening here. So that negative would need to go away. So I'd have a 3x plus a 2y equals something. I do not care what that something is. I just want to make sure that I have the 3 in front of the x and the 2 in front of the y, and that the sign's going to change. Therefore, it's going to be the opposite reciprocal. All right. That's a little bit harder to understand. I think most of us are probably pretty good with changing to slope-intercept form. So I think that's a method that I would suggest for most of you. Hope that helps. Which of the following is an example of a function whose graph in the xy plane has no x-intercepts, meaning it does not cross the x-axis? Other words we associate with x-intercepts are often zeros, solutions, things like that. So our first choice is a linear function whose rate of change is not 0. That would mean it would look like any line that's maybe sloped like that. It could be vertical because that rate of change is not 0. A horizontal line has a rate of change that is not 0. All of those are going to cross the x-axis. So it's definitely not A. How about a quadratic function with real zeros? Well, with real zeros, that means it crosses the x-axis, right? So that would not work. That would look something like this. It has real zeros. Okay. Next up, we have a quadratic function with no real zeros. Well, if it has no real zeros, that means it never crosses my x-axis. It might look something like this. So my choice here is no x-intercepts, going to be C. Woo! According to the system of equations above, what is the value of x? Since I have x plus y equals a number, x plus 2y equals a number, I'm going to go ahead and use elimination method, my personal favorite. So what I'm going to do here is I want to cancel out my y's, which will allow me to solve for x. I don't even need to plug back in like I normally would because it's only asking for x. So I'm going to start by multiplying this top equation here by a -2 so that my y's cancel. Let's rewrite it. So now I've got my two equations, right? The second one is the original. The top one there is multiplied through by a -2. And I'm going to end up with, let's see here, that'll be a -x. The y's cancel equals, and that's -7. So now that means that x is going to equal a +7. I can bubble that 7 wherever. I'll just throw it here at the end and boom, fill it in. 7. We are donezo. That was awesome. I love me some elimination. Just eliminated that problem from my to-do list. If the system of inequalities y is greater than or equal to 2x plus 1 and y is strictly greater than 1/2 x minus 1 is graphed in the xy plane above, which quadrant contains no solutions to the system? All right. So it's either 2, 3, 4, or all of them have solutions. Let's see. How about we start just by graphing these in the given graph here? You could also graph them in your TI-84 plus since this is the calculator portion. Here I'm going to start up at 1. There's my y-intercept, and I'm going to go up to 1, 2, and over 1. That'll be my next point. I can also go down 2 and to the left 1, which would give me another point, and then I'll go ahead and connect this with a solid line best I can. And since it's greater than, that means I'm shading above the line. So right now, I'm in quadrant 1, 2, and 3, but I'm not in quadrant 4. So really at this point in time, I could actually just select choice C here, where there's going to be no solutions because it has to be the overlap of the two of them. And if the green one's not going to exist in the fourth quadrant, there's no way my overall solution can fit in that fourth quadrant. But just for fun, because who doesn't love graphing inequalities, let's go ahead and finish this one out. So if I do that, I'm going to go ahead and start down at -1, and I'm going to go up 1 and over 2, so right here, and that means I can go down 1 and to the left 1, 2, and I'll be right over here. That's going to be a dashed line. And then I'm going to be shading again above since it's greater than. And as we can see here, the solution is existing for the overlap is existing in 1, 2, and 3, but there is no overlap in that fourth quadrant. So our solution, our answer is still the same. We are most definitely choosing choice C there, quadrant 4. That was awesome. Have a great day.